Right, these are the answers for 2.1 Equilibrium Fact File. So question 1, the reaction of bromine with water can be represented by the following equation. With bromine and water gives us bromide ions, OBr minus and 2H plus. Which one of the following reagents would move equilibrium to the right? So if we look at the equation on the right hand side, we have bromide ions, we have this OBr minus, and we have the hydrogen ions. So we can rule out the acids. If we add sulfuric acid or nitric acid, they're both going to add H pluses. And that will shift equilibrium then to the left because the system will compensate to remove the excess hydrogen ions that appear. So we can rule out those two. Sodium carbonate, as you know, will react with acid in neutralization. So it's actually going to react with the H pluses to remove them. And what that means then is it's going to drive equilibrium to the right. So sodium carbonate would in fact have the desired effect. And just then to check the last one, sodium bromide, that would give us the bromide ions, which appear on the right hand side. Increasing the concentration of the reactant on the right hand side, it's going to cause the reaction to compensate and move equilibrium to the left. We can rule that out as well. So the answer is indeed B, sodium carbonate. Part 2, the second stage in the production of nitric acid involves the reaction of nitrogen monoxide with oxygen to form nitrogen dioxide. So when nitrogen monoxide and oxygen are mixed under suitable conditions, a dynamic equilibrium is established. And the equation is given. We've got NO and O2 gives us 2NO2. And you'll notice that the enthalpy change here is minus 116 kilojoules per mole. So explain what's meant by the term dynamic equilibrium. Well, you have to say two things here. So it's just really your definition of dynamic equilibrium. So the first thing is that the rate of the forward reaction is equal to the rate of the reverse. Okay, so that's one mark for those two, or for that, for saying the rate of the forward reaction is equal to the rate of the reverse reaction. The second mark then is for saying that the amount of any given product or reactant remains constant. So that's your second mark. Now, state and explain how increasing the pressure will affect the equilibrium yield of nitrogen dioxide. So if we go back and look at this equation, on the left-hand side here we have 2 moles of the NO and just 1 of the oxygen. On the right-hand side we have 2 of the NO2. So there are more moles on the left-hand side here. There's a total of 3 compared to the 2 on the right. So that means that equilibrium will favour the side with fewer moles. So that's what we need to say in our answer. So stating it first, we're going to say, I was asking actually how it will affect the equilibrium yield. Okay, so it's going to increase. So that's 1 mark for stating. And then our second 2 marks are for explain. So we could say we have 3 moles of gas on the left-hand side and 2 moles on the right-hand side. And then, so equilibrium shifts to the right. To oppose the change. And in fact, there's only 2 marks for that question, so there's just 1 for that whole blurb there in the second part. But it's given the idea that there are more moles of gas on the left, so equilibrium will shift to the right to oppose the change. Okay, C, explain how increasing the temperature will affect the equilibrium yield. So you remember here that the overall enthalpy change was minus 116. And I like to think of the little diagram. So you have your reactants and your products, and then it's going down, so it's negative, which means it is an exothermic reaction. So that means that if you increase the temperature, it's going to shift the reaction in the opposite direction. It's going to go backwards to try and cool the system. So the actual, it says again, how it will affect the equilibrium yield. So the yield will decrease. So that's stating what's going to happen. And then explaining, so the forward reaction is exothermic. And then you're going to say, so equilibrium shifts to the left-hand side to oppose the change. And again, there were just 2 marks for that, so 1 for stating, and then that second mark for explaining. So for D, it says state and explain the effect a catalyst has on the equilibrium yield. Well, unlike rate, catalyst has no effect on yield. So 1 mark again for stating. And then the explanation is that it increases the rate of both forward and reverse reactions equally. So no effect because both the reaction rates are increased by the same amount. So next it asks about the temperature and pressure used in the production of ammonia by the Haber process. And this is one that you really do need to learn. So what the mark scheme says is between 400 to 500 degrees C. So that's 1 mark for the temperature. And then 200 to 300 atmospheres for the pressure. So you probably would have been taught 450 degrees and 250 atmospheres, but anywhere in that range would have been accepted. And finally it says, why is the temperature used in the Haber process described as a compromised temperature? Well, a compromised temperature means that you're taking into account both the rate and the yield. It's no use if you have very high yield for the reaction if it only occurs very, very slowly. So what you need to say here is that it's a compromise between rate and yield.